Hey, good morning, guys. So today's lesson is Investigation 1.4. It has to do with rectangles and factor pairs. At the end of today's lesson, hopefully you will know how do you know when you have found all the factors of a number. So that's our goal today. That's our focus question. So start off with some vocabulary. My beautiful writing, if you can read it. A factor pair. Right. Well, a factor pair is two numbers that, when multiplied together, make a product. So any two numbers that are multiplied together that make a product. So examples might be 1 times 12, 2 times 6, and 3 times 4. Those would all be factor pairs that have a product of 12. A square number. So a square number is when both factors are the same. And examples of a square number would be 2 times 2, right? 3 times 3, 4 times 4. Both those factors, like right here, right? Actually, I can do it with this. So 2 times 2, 3 times 3, 4 times 4, 5 times 5, 100 times 100, 150 times 150. As long as they're the same, they form a square, and it's called a square because it is like it's 2 this way and 2 that way, right? And it makes a total of 4, so it's a square. Okay, so first question is, imagine you have 12 building blocks, Legos, Unifex cubes, whatever, but they're blocks that are going to be squares that you're going to build. You may have used these in kinder. How many different ways could you build rectangles? Well, you might be able to build tall rectangles that stand really tall and ones that lay kind of flat, maybe more rectangular blocks, right? So I went ahead and let's talk about a few ways. So we're going to draw as many examples as we can. Well, you're seeing all the answers, so hold on a second. Let me pause this. Okay, so there you go. So you're going to draw out as many as you can. So this is this is called a column that goes up and down like a building. And it has 12 that go up. So it's a column of 1 and has 12 rows in it. The next one, right, and 1 times 12 is 12. The next one, it's a little shorter, so it's 2 columns, and it has 6 rows, or 6 floors, like in the building. And we have 2 times 6 is 12. We have 3 going up, and 3 times 4 is 12. And you can kind of see the difference. It goes in a very predictable order. 1 times 12, 2 times 6, 3 times 4. And we know that this is the last set of factor pairs because now they're going to reverse. So now you need to reverse them. So when you reverse them, instead of it being a tall column, it's going to be basically one row high by 12 rows. I'm losing my mind. I'm so sorry. So it's 1 by 12. It's just different. So this one's tall and skinny. This one's short and fat. So you can imagine that this next one is going to be like flipped on its side. So it's going to be 6 by 2 high. So there you go. It's 6 this way and 2 high. And then the next one, these two numbers are going to change. It's going to be 4 by 3. So you can see it there. Okay, so go ahead, and if you haven't had a chance to write those in, go ahead and write those in, pause the video. Coming down here, scoot this up a bit. How is this activity related to our previous lesson? And then what do all of the rectangles for the number 12 have in common? So think about those first two questions for a minute. Pause the video, think, and then unpause. Well, how was this activity related? Well, it talked about factor pairs. 1 times 12 creates a product. So yesterday we were playing the product game, right? And we were taking the markers and moving them around and thinking of the products they made, and those are factor pairs. So that's the connection there. And then what do all the rectangles for the number 12 have in common? Well, they all share a product of 12. All of their factors are, when multiplied together, equal 12. Okay, so now if you were given 30 blocks, you're going to have to do this with the number 30 now. So what are all the factor pairs of 30? A good idea might be to write out all the factor pairs of 30. I went ahead and started here. You can see it's 1 times 30 equals 30. 2 times 15 equals 30. And I might write them up here. 1 times 30, 2 times 15, 3 times 10. Notice they're getting closer. There's less choices now. 4. Is there a number 4? I don't know. And then maybe it's 5 times 6. And then it's going to reverse on you, right? Because now I know there's no numbers between it. That's how I know I found them all. Now it's going to be 6 times 5, 10 times 3, 15 times 2, and 30 times 1. Now when you compare these, right, you might say, Mr. Cox, these two right here are the same, but in actuality, those are very different. Okay, this is 1 by 30, so it's tall and skinny. This is 30 by 1, it's short and fat. When you turn the page, there are going to be more boxes, so you just going to make sure that you draw these arrays, which is what they're called. Don't worry about putting 30 lines in there. There's no way. It's going to be too tight, or even 15. Once you get down to 10, you could probably do it, but for those other ones, don't worry about it. Okay, so I did the next one for you, but I want you to pause the video. I want you to try them and then see if your answers look similar to mine. So it's 3 by 10. 3 times 10 makes 30. And you guys go ahead, and so we have that one done, we have that one done, we have that one done. This box should be 5 by 6, so go ahead and try that. So pause the video, draw your arrays, and then see if they look like mine, and just when you're done, start the video again. Okay, so hopefully you got those all drawn out. You have the 1 by 30, so it's 1 wide by 30 tall. This one's 15 tall by 2. This one's 3 by 10 tall, right? So 3 by 10, right? And then it's 5 by 6. Then we flip it over, and then they change, right? So it's 6 by 5, 10 by 3, 15 by 2, and use your imagination that there were 30 boxes by 1, so very short and fat. So on to the next one. To help the class find rectangles for their exhibits, the school made models. The models show possible rectangles formed by carpet squares. Remember carpet squares in kindergarten? You probably had a square to sit on. Anyhow, the models for the numbers of 15 are shown. So here's the models they have for the carpet squares. Your teacher will assign you your group a few of the numbers from 1 through 30. For each of your numbers, complete the following. Write the number at the top of a large sheet of paper. We're not going to be able to do this. We're going to do it right here. Cut out all the models, right? And then tape all the models to the paper with each model with its height. List the factors and number from least to greatest at the bottom of the paper. So basically, they've done the number 15. So you have to find, so I'm going to give you a number. And let's say that number is, let's say it's 18. We're going to work with the number 18. So what you're going to do, just like for 15, they drew all these little shapes out. You're going to write out all the factor pairs for the number 18. So it's going to be 1 times 18. I hope you know these. 2 times 9. 3 times 6. Okay, are there any more? I know 4 and 5 don't go into 18. Now, you're going to need to draw these shapes. So you're going to have like a 1 by 18, a 2 by 9 down here, a 3 by 6. And on the other side, it's going to flip. You're going to have, just like they drew it here, it flips. So it's going to be, instead of being 15 by 1, it's going to be 18 by 1. It's going to be 9 by 2 and 3 by 6, because those are also equal to it. So go ahead and draw these shapes, right? So you can count out 1, 2, 3, 4, 5, 6, 7, 15, 16, 17, 18. So right here. And I'm going to use a highlighter just to make it easier to see. Okay, so this is going to be a 1 by 18. 1 by 18. And over here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 18. So over here, this is going to be an 18 by 1. Alright, that's not a very good job. Oh, and you can't even see it. Oh my gosh. So I counted up to 18 this way, and then this is an 18 by 1. So there you go. And then you're going to do a 2 by 9 somewhere on here, and then a 3 by 6. So go ahead and try that, and then we'll come back together in a minute. So pause the video and do that. Alright, so hopefully you're done. So I got a 1 by 18. I got a 2 by 9. And it's a 1, 2, 3, 4, 5, 6. I have a 3 by 6. And you can see over here, very poorly drawn by Mr. Cox. Let me see if I can make that better. Part of math is being neat. You need to be neat when you do this. And I'm going to have a 1 by 18. This is a 2 by 9. And this is a 3 by 6. Okay, so if yours doesn't look similar to that, and you may have them drawn other places, that's great. I'd also like you to try doing another number. Let's do 12. Do 12 up here somewhere. So the next number I want you to do is a number 12. So do the same thing you did for this, but do 12 up here. Go ahead and do that now. Okay, so now I'm complete with mine. So make yours, if yours is similar, it should look something like that. And what we notice, these tall, skinny ones, right? The ones, they're tall, skinny, or short and fat. And then as numbers get closer together, they become more square-like. They become closer to looking like a square. Okay, so now we have some questions to think about. So these are all numbers 1 through, let's say 1 through 30. Okay, so which numbers in 1 through 30 do you think would be represented by the most rectangles? So looking back, okay, these only have 3 different rectangles that you could see. Are there any numbers 1 through 30 that may have more rectangles? Well, start thinking about the factors that make a number. Go back to the factor game. Which numbers had the most factors? Which ones got you the most points? And those are going to be the numbers that you're going to write in here. So think about the numbers that have the most factors, and those are going to have the most rectangles. Okay? So these numbers have what in common? They have, right, lots of factors, right? What types of numbers are often like this? These are probably going to be numbers that have lots of factors. I'm going to tell you the answers in just a minute. 2. If you have ideas, you should write them in. All right, for 2, these are numbers that have the fewest rectangles. What do these numbers have in common, and what kind of numbers are these? So think back to the factor game. Which would be, these are numbers that have the fewest amount of factors. So these were the best first move numbers, if you remember what those are. And those special kind of numbers. Numbers represented by a few rectangles. These are actually where you're going to write the numbers in, okay? And then down here, these numbers have what in common? Probably not a lot of factors. These types of numbers are often, and you're going to tell me what kind of numbers are those normally? They're a special name. Just like these ones have a special name. Okay, so once you have that done, these are square numbers. It says a number that can be arranged to form a square with tiles is called a square number. So it's equal height and it's equal width. They're the same. Which numbers are squares? And what do you notice about factors of square numbers? So from 1 through 30, think about square numbers. It starts with 2, and then goes to 4, and then goes to 9, right? So can you finish out the square numbers through 30? And then the factors of a square number are what? So what factors make a square number? So it's the sides and the height are specific. So that's what they're asking. What kind of numbers are they? Or how would you classify them? And then how can you use the rectangle models for a number to list the factors of a number? Use examples, show your thinking. So how are these models? How did you figure out this is 1, this is 12, right? How did you figure this was 2 and this was 6, right? You could literally count them up, right? So I think that's what they're asking there. Go ahead and write that in. Okay. I'm going to come back. We're going to come together tomorrow and talk about this. Suppose a class has 12 square yards for their exhibit. So they're having an exhibit like at a fair, and they have to decide what shape they want to build their exhibit in. And you're using the number 12. Which rectangular shape would the class select for the arts and crafts show? What are the advantages and disadvantages of the shape? So this is you thinking about the number 12, right? So which shape do you think would be best for the exhibit? You can pick any one of these 3 shapes, right? Or these 3, which are the same, but just a little bit different. Okay, so down here, I think the class should select a rectangular shape size, and they want numbers like 1 times 12, 2 times 6, 3 by 4 for the arts and crafts show because, and you would write that in. I think a shape that would be a disadvantage, so not a good shape. I think the shape can be a disadvantage when. So what would be the reasoning you wouldn't pick one of the style shapes? Okay, so we're going to go ahead and complete that as best you can. We will come back together at 12 o'clock today and review all of this stuff and hopefully answer any questions. If you get stuck, just stop and see and move on and do the best you can. All right, guys, I'll talk to you in a little bit.